Alright, in this video we're going to look at printf, and we're going to do this by having a look at a short program. So we're going to start off with a new program. I've called it formatspecifiers.c, a nice meaningful name for the problem. I've saved that into my lab 0 folder, and all I've written so far is the template because I want to make sure that that compiles before I continue. So I'll first make sure that we're in the right folder. We're working in lab 0 again, and we should see our formatspecifiers.c, which we do. So I'll go ahead and compile that and just make sure that there's no little mistakes at the moment. So that all compiles perfectly fine. There's no point running it at the moment because we don't have any printfs. So we'll just leave that for now and come back here. Now what we're going to do here is we're going to declare some variables, and we'll also do some initialization so that they all have values straight from the start. So the first one we're going to use is car. Now a lot of students get confused by car. It is an integer type, but we usually store ASCII characters in it. And we'll have another video on ASCII characters to make sense of why it's an integer. But for now, you can just think of it as storing a character. So we're going to call this grade, okay? And I'm going to assign it the value B. Now you'll notice that this has little quotes. This indicates that this is a character literal. Okay, remember that anything that is literally a value is called a literal. This here is called a variable, and this here is called the type, and this here is assignment. So we've got the literal B. So anytime you want to store an ASCII character or a character, we need to put these single quotes here. Okay, I'll explain what ASCII is in another video. The next one is a little bit more confusing, and I'm not going to fully explain it right now as it's actually rather complex how it works. But what we're going to do is we have to use it a little bit for now for some of the things that we're doing. So we're going to see this quite a bit early on, and then we'll understand it a lot later in the subject. So here we have car name and then these square brackets, and then we have double quotes with a sequence of characters. Now we usually refer to a sequence of characters as a string, and a string literal is indicated by the double quotes. Now to store a string, we need this special type that has these square braces here, and we'll look at what that means a lot later in the subject. So I'm going to create 2 of these strings. So I've got the score. And the next one I'm going to create is just another integer type. Now another thing that students get confused by is int. Int isn't the only integer type, okay? Remember that short, long, car, and int are all integer types. Int just has a special name that represents integers, but the others are all integer types as well. They just store whole numbers. So I'm going to write 18 here, okay? So 18 is the literal. It's just a decimal literal, okay? We're going to put a floating point type, so this is a double, and we'll put the literal 19.8 there. So at this point I'm going to go and save and compile. Now I recommend, because you're very early on in this subject, every single one of these lines you should compile, okay? If you've got mistakes and you're asking how to fix them and you've written all this, then you're not following a good workflow, okay? If you're very unconfident, every single line, write it and then compile, Okay, even professionally, whilst you might not do every single line, after about this amount of lines you should compile. So we're going to go back and compile. Now, what we notice here, and this is why it's important to compile, is there's no errors, okay, which is good. But we've got these warnings, which says unused variable. Now, I can ignore that because at this stage of the program, yeah, it's unused. We haven't used it yet. So all the compiler is telling you is you've made a variable, but you haven't used it. You're being silly. But we haven't finished the program yet, so we can ignore these unused variable. If I got to the end of the program and I had an unused variable, then I'd be worried. And then I'd have to go back and try and find why I have an unused variable. But at this stage, it's fine. Now I'm not going to bother running it because we don't have any outputs. Alright, so the next thing is our printf. And we saw this last week with our hello world example. Now, this will print text to the screen, and that's perfectly fine, but we want the information printed to the screen to be variable, to be dependent upon things like what the user enters. So what we're going to do is, I'm going to write something a little bit different. So I'm going to write %s plays %s. And I've got a comma there. Okay, the commas are important. And I'm going to write name. And I'll just spread this out a little bit. And sport here. Alright, so what have I done here? So here I've got my printf and I've got my string, as you've seen previously, like hello world. But this time I've got this %s. So these are called format specifiers. And they specify the format of what you would like printed there. So I would like a string printed here and a string printed here. Now, that's good information because it tells printf that we want to put a string here and a string here. But we also need to tell it which string. So you'll notice these commas with name and sport here. So the first argument after the first string, and we'll learn more about functions a bit later, but basically your arguments are separated by this. So the first argument after this is name, and so that's the string that will be printed here. Same with sport, that is the string that will be printed here. Okay? So it's important that these are strings because remember early on when we talked about information retrieval, if we have the wrong type here, it's just going to print out garbage. Okay, so we need to make sure that we provide the right type here. So let's save this, compile, run it, and test it, and see if it works. So we'll compile that. You'll notice straight away that the unused variables are gone for name and grade and name and sport because we're using them now. And now we will run this, and we see that it says Josh plays football. We've got a logical error. Okay, we're missing a /n. So we'll save that, come back in, and then redo it. Now the reason that I'm trying to emphasize this point of testing, checking for logical errors is because if you don't do this and follow this loop, you will really struggle. Okay? It's easy, it's quick, there's no real excuse. Alright? Okay, I can quickly pick up that mistake and fix it. Okay, so where do you find this information about the format specifiers? So on your lab reference sheet, you'll see this big list here. Okay? So firstly, you've got all the format specifiers. So %C, %S, %LF and F, and %D are ones that we're going to be using quite often. Now, we talked about information retrieval, and we need to provide suitable information for these format specifiers. So I've provided the suitable types here. Okay. Now you'll notice, for example, decimal integer takes an int, and so does hexadecimal. It also takes an int. So remember back to information retrieval. Depending on how we read that information, we can represent it in different ways. So I can read it and print it out in decimal, or I can read it and print it out in hexadecimal. Okay, so you can have a play around with that when you want, but you've got the list there. We'll end up using all of these, that's why they're here, but there's only a couple that we'll be using right now. So let's go back into our code. So the next thing I want to do is introduce an integer, so %b, %s. We're going to introduce a character. Okay, so this is an ASCII character. %s. Now, this is important. So we've got 1, 2, 3, 4 format specifiers. So that means there's going to be 4 arguments appearing after the string. Okay, so we're going to have 1, 2, 3, and 4. And we need to fill those in. So first one's going to be age. Next one's going to be name. Next one is going to be what have we got? Grade. And the one after that is going to be sport. And we'll put a slash in there as well. Alright, so we'll save, compile, test that out. Okay, once again, following that workflow. So cool, it's only a warning, we haven't used fees yet, and we can see that this is working. We've got Josh plays football on one line, and then we've got 18-year-old Josh plays B grade football, sorry. Now the next one we'll have a look at is going to be fees for playing %s. So we've got LF for a double. Okay. %s. %LF. Okay, so here I want to print the same thing twice. So I want to print the fees out twice. Now, because of that, I will need to still write the variable twice. Now, just one other thing, you can put a literal here, but it's rather redundant. We can have a look at that if you're interested. So, first one's going to be sport, next one's going to be fees, next one's going to be not sport, it's going to be name, sorry. And the last one's going to be fees. Alright, so I'm going to print that out and we'll see a small problem with this. Okay, so with our floating point number, you'll notice that we print out a lot of extra decimal places. So we've got all these zeros floating at the end. So we need to have a look at width and precision. So let's go back here. Oh, that's not where I want to go. I'm going to go here. So there's some more information that we can include on our format specifiers such that we can get extra information on here. And there's some questions for you to play around with and test, but the one that you'll be using quite often is this precision, okay? And this specifies the number of digits to display after the decimal point. So we'll go have a play with that one first, and then we can have a look at the other ones after. Where am I? There. So if I want to show this to 2 decimal places, then I'm going to put this extra bit of information here. So this is my precision. So I'm going to write 0.2. And here I might write 0.1. Okay, so I'll save that. I'm going to go back in wherever I am. Did save. Yeah, did save. Compile, run. So you'll notice here that I get 2 decimal places. Here I get 1 decimal place. Okay, so by adding that 0.2 at the front, I limit the precision. Right, so we'll have a look at width now, and we'll use these again to do this. So I'm going to write percent, let's say 10.1 LF. Now this could be with your other variables as well. Your width will work with your age, your sport, your name, your grade. The precision is more so for floating point numbers though, okay? It doesn't really matter on integers. So, that's these. Okay. So here, what I'm doing is I've got a width of 10 and a precision of 1. So the precision means that it'll have 1 decimal place. A 10 says that's the minimum width. So to make sense of this, we'll go and print this out. So here you can see that this line here, if you actually go ahead and count up every single one of these characters, so 3, 4, 5, 6, 7, 8, 9, 10, you can see that this 19.8 at minimum takes up this room. So this is really nice when you've got tables and you need everything to line up perfectly. And you can see that as I change the width, that changes. Now I can do this for my age as well. So I can change this to the D. Now you'll notice that I remove the precision because I don't need it for an integer. And then we'll change all these to age. Save that. And we'll run that again and we can see the same thing. Now, if we did something like this, okay, you'll notice that it still prints the 18, but that takes 2 spaces, and I've said 1 space. So the width is the minimum width. If the number is larger than that, then it'll just print it out. Now, there's a couple of other ones. Where's this? Which is your flags. So you can left justify, okay? So you can notice that everything here is right justified, so it's on the right hand side. You can left justify as well. So if you want to left justify, we just add a minus at the front, so that'll left justify age. So for example, I'm just going to put the letter X after this so you can see the left justification. Okay, so you can see that it still takes up 10 characters, but it's on the left hand side. We've got, what else have we got? We've got always display sign. So this means that if it's positive, it will display a plus at the front of the number, and if it's negative, it will display a negative. The reason you may want this is because you'll always get the negative symbol, but you won't get the plus, and when you need things to line up so that they have the plus, this is handy. I'll let you try that one. Display space if there's no sign. So another handy one, so if it's negative, it'll put a negative. If it's positive, it'll put a space where the sign should go. And this one's also handy, pad with leading zero. So we might try this one out. So let's go back. So here I'm going to put 0, 9, 0, 8, and I can do this with this one as well. Doesn't really matter. So what this is going to do is going to pad with leading zeros. So let's have a look what that means. So all that does is in front of the number puts a bunch of zeros. We've specified the width must be 9, so it must take up this space, and all that extra space in front, so leading, will be zeros. This one, there is no extra space, so there's no other zeros. Alright, so there's a lot to play with here, and there's a bunch of questions in the lab that you can test out. So go ahead and try that out. Thank you very much.